Welcome back, grade 12s. Wow, such awesome answers, such awesome questions. And as I said before the break, now is the time to send in any more questions that you guys have. And remember that the challenge question is up on the page. So, in case you haven't seen it, block your eyes to all the answers and answer it yourself. Remember to also maybe explain a little bit how you got to it. And remember every detail of your answer for all 7 marks. Over to you, Dina.
Thanks, Katlego. Yes, Katlego's right. Remember every detail. So remember we spoke about earlier at the start, whenever you have a general solution, that you need to give the detail on K as well. So we're waiting for those answers. We'll reveal the answer at the end of the show. Right, for now, we're going to look at the other component of paper 2, and that is the section called coordinate geometry. And coordinate geometry, or analytical geometry, whichever way you want to call it, is a geometry that is done on the Cartesian plane. And for those of you who don't do paper 3, then there is only one aspect of the Euclidean geometry that we use in coordinate geometry, which we'll look at now while looking at the next example. Right, coordinate geometry, and the example I'm going to do with you is as follows. Maybe you want to take it down. AB is a tangent to the circle defined by, and then we have the equation here. So that's the equation of the circle. And we've got a tangent to the circle at B with point xy. A is another point on the graph, and the question is to find what is the length of AB. Okay, that's our job, to find that length. Right, as I always like to start, I'd like to find focal areas, tips on how to go about coordinate geometry. It is imperative that you don't try and do this mentally and in your head, but that you actually draw a diagram so that it becomes like a cue card sort of process where you're looking at the clues and it's giving you certain clues to the next part of the problem. So it's imperative that you draw what you are looking at. Otherwise, you can't make judgments on whether what you're doing actually makes sense, and you can't verify it. So it's absolutely essential that you actually draw what you are doing. It doesn't have to be perfectly drawn, but it's somewhere where you can put your thoughts on paper and be able to argue whether that gradient actually makes sense, because my line is lying like this, but my gradient is positive. Does it make sense? Am I sure about that? So it's imperative that you have a diagram to work with and that you argue with the values that you're getting from the diagram. So with that said, let's draw what our diagram is all about. So we've got a circle that's defined by that. And before we actually start drawing, because we've got this equation, I actually don't know some information that is critical for me to be able to draw. If it is a circle, what exactly do I need in order to draw that circle? Am I just going to place that circle anyway? No, I need its center. So before I draw, I want to know, where do I begin? Where is the center of the circle? So how do I work out what is the center of the circle? How do I go about extracting from all this information what that center is? Okay, there is a formula on your formula sheet that says that my center will be extracted if I've got the equation in this form. Okay, so I've got to have a squared bracket in x, a squared bracket in b is equal to r squared. Then I can extract the center as being AB. So I want to be able to do that. So how do I now get this into that format? Okay, I've got x squared, I've got x, I've got y squared, I've got y. I'm going to group them, and I'm going to factorize the x's and the y squareds. So it looked very complex and mixed up and a very diamakad, but it's actually quite easy, because we just take the x's, we take the y's, and we factorize those, and we'll have those two perfect square brackets ready for us to extract the center. So let's get to it. Right, so we've got, as we said, we're going to collect the x's, so we're going to have x squared plus 2x plus y squared minus 4y. I'm actually running out of space here, so let's just go down here. We're going to do it over here. So x squared plus 2x plus y squared minus 4y equals 3. Why do you think I have left a gap between the x's and the y's here? It's because it's not just about factorizing. Yes, I want to be able to factorize so I can get that perfect square bracket. But before I can factorize, it's missing a constant. And it's this constant that I want to fill in order to be able to factorize into two squared brackets. And for those of you who have been through grade 11, you will know that we call that the completing of the square. So we're going to complete the square. What must I add in here in order to be able to factorize into a perfect square? And we've got a process for that. We would take half of 2 is 1, and we would square it, so it would be plus 1. So if I add 1 on, I'm going to be able to factorize. Half of 4 is 2. 2 squared is 4. So I'm going to add plus 4 on this one. Now, the equation was in white. I've added the 2 yellows, so that gives me 5. So I've got to balance it on the right-hand side, and I've got to add 5 as well. So what I've done to the left, I'm doing to the right. I've got to add the plus 5 here as well. Now, we've said that if we complete the square on x and complete the square on y, we are going to be able to factorize into these two squared brackets. So we now have x plus 1. Does that factorize? Yes, because I double to get to x and I square 1 to get 1. And this factorizes as y minus 2. Be careful with the signs. It's a negative in the middle, so I need a negative in the middle here as well. But if I square negative 2, I get the positive 4. So I've been able to factorize into perfect squares. So my equation of the circle is x plus 1 squared plus y minus 2 squared is equal to 8. So what information do I now get from the equation that's written in that form? Remember, it was written up here like that, but I can rewrite it to be able to extract its center. And we complete the square on x and on y to be able to extract its center. If you multiply out again, you're going to be able to get that long equation, but we can't extract any information from it. Okay, it's not useful in that form. So we now have that the center is always the additive inverse of 1, which is negative 1, and it's the additive inverse of negative 2, which is 2. So we get the center of the circle. That's what these values here are. So if you think of x squared plus y squared equals r squared as the center being 0, 0, this center has translated 1 unit to the left and 2 units up, and that's where we'll find its center. And another very interesting thing that we find is that this 8 represents the value of r squared. So we are able to also find that the length of the radius is root 8. And since radii are positive because they're distances, we're not going to look at negative root 8. So two very important things we can find. We can find the center and we can find the radius of the circle. Okay. Right, now, remember we started saying we need to draw so we can picture what's going on, but we didn't have a center. So we went to find the center first. And now that we have the center, let's put that information on the picture. Right, we're ready to do that? We've got a center at negative 1 and 2. And we've got a radius of very close to square root of 9, which is 3. So it's very close to 3. So I think that the radius would go till about there. So I'm going to draw a circle that would somehow fit that description. Okay, and remember this is to give us a gauge as to what's going on. So it doesn't have to be perfect, but we are able to see and to test what's going on. So, right, we've got a negative 1 and a 2 here. And then we've got a 0.84. Now, 0.84... that was given, is a point somewhere over here. And let's go back and see so that you are with me. Right, so A was a 0.84, and it's touching the circle, or the tangent. Go back to what's important. AB is a tangent, and it touches a circle at point B, x, y. So those things we now need to put on the diagram. Where the tangent's touching, where that other point is. So let's go down and do that. So we've got point A out here. And we've got, there's a tangent AB, so I'm going to make it there. And B is going to be here, XY, because remember it touches at one point. And we would like to find that length. Okay. So with this kind of empty diagram, you've got to begin to argue. Exactly what do I know? What else can I fill on the picture? What else have I worked out or calculated that I can draw in? The moment you have this tangent that we've worked with, okay, remember that this was a tangent, there is a property that comes from Euclidean geometry, and that is that all radii that meet that tangent will always meet it at a very special angle. They will be perpendicular to each other. So I'm going to, the moment I find a tangent, I'm always going to draw the radius. It's going to be one of those magic cues, or magic clues, should I say. And when I've drawn that radius, I'm going to fill in that it's perpendicular. So you will always draw the radius. And can you see, if I'm not going to draw these things, if I'm trying to do them in my head, I'm not going to see the radius, I'm not going to see the perpendicular, I'm not going to see anything. So it's imperative that anything that's wordy and lengthy that you can construct into a diagram, you will find great benefit to finding those clues. So we've got drawing of the radius. Why do we do that? Because my radius is always going to be perpendicular to my tangent. It is one of the properties of these two lines. They will not meet at any other angle except at 90 degrees. Okay, and then I think the other thing that we begin to see is that, hey, if I've got 90 degrees, then what two special properties do I have when I'm working with 90 degrees using graphs? Well, the first one is that we'll have perpendicular lines, so we could use that. And what do I mean about perpendicular lines? Exactly what about perpendicular lines can I use? Is that the product of the gradients is -1, okay? And the other very important thing, which is always lurking, it's been lurking since grade 8, is that I can always use Pythagoras, okay? So perpendiculars are critical because they offer you two options to travel. One, am I working with gradients? Two, am I working with Pythagoras? And we've drawn the radius in here, and we've got to make a decision about those two. But can you see that the radius is √8? So I'm going to fill him in as √8. And I'm also going to draw, since we were talking about whether we should use Pythagoras, I'm going to draw this line in, because the only way I can use Pythagoras is if I've got a triangle. And by drawing this green line here, this is actually the hypotenuse. So what I've actually constructed is a right-angled triangle where I've got this length. The whole thing that I've been asked to do is to find this length over here. I've been asked to find this yellow length here. And the question is, do I know how long the green line is? Is it possible to find the length of the green line? Well, of course. I've been given, again, if we're not going to put these things on, they're not going to jump at us, but I've been given A as 8,4. I've just worked out the center as -1, 2. This little 2 is hiding there. And therefore, I certainly can work out what the length of, let's call this O, of AO looks like. And then, since I can use Pythagoras, I can find out what AB squared is. So let's calculate the green line. The green length is AO. And the distance of AO squared would be 8 plus 1, which is 9 squared. And it would be 4 minus 2, which is 2 squared, so it's +4. So AO squared is just 85. Okay, so that's my green length squared, which is my hypotenuse. So if I'm using Pythagoras, then my yellow length, AB squared, would be what? Hypotenuse squared minus √8 squared, so it would be 85 minus √8 squared would be 8. So AB would be root of 77. Pay attention to the instruction. If the instruction doesn't say anything, then the way that you leave the answer is not a problem. But if the instruction specifically says leave your answer in third form, then please don't use the calculator, because again you get penalized. And out of 12 questions in each paper, if you're getting penalized, 1 mark here, 1 mark there, doubling those marks across 12 questions gives you 24 marks that you're losing on technicalities. So be very alert. Instruction, instruction, instruction. That's imperative. No instruction, well, I can leave my answer anyhow. But if there is an instruction, please follow that rigorously. Right, so AB was root 77. Now, you could argue that this doesn't really help me to see whether my answer, or to make a judgment around whether my answer is valid, but sometimes it's not only about the answer, sometimes it's about the process. If I didn't have the radius and my tangent, which the question didn't alert me to at all, I would not have the hypotenuse as the green line, and I would be completely lost. So, imperative to draw your diagrams. I think it's over to Klehu.
Thank you, Dina. Guys, so it is time for a break. I know that there are some questions, so I'm going to show them to Dina during the break, but please don't stop sending in your questions, and especially don't stop sending through the answers to that challenge question, because we will be looking at it later on. See you after the break.